All right, guys. So we have concept of pressure, right? Pressure mode. We're going to talk specifically about what? Barometers and manometers. So to do that, we need to first understand a few basic concepts of pressure that I think তোমাদের already জানা আছে. Pressure is equal to force by area. ঠিক আছে? ওইখান থেকে you can derive the formula used in fluids. ঠিক আছে? What's the formula used in fluids? Pressure is equal to H rho G. ঠিক আছে? So in barometers and manometers, we need to talk about pressure is equal to H rho G. So first of all, so if you take pressure is equal to H rho G, let's understand a few basic concepts. If you have a tube which is say very narrow, very long, and it has a certain height, the whole tube has a certain height h, and the density of the liquid, they say we fill it up with the liquid, say water, pura liquid full and the density of the liquid is rho. Now what's going to happen is, if both ends of the tube is open, and Dora, you put your hand here, at the bottom of the tube to stop the water from falling out, your hand will experience a certain amount of pressure. Pressure ta kototuku hobe? How would you know? It's going to be basically the pressure due to this entire column of liquid. So the pressure is equal to, very simply, h, which is the vertical height, eta perpendicular height nite hobe, rho, which is the density of the liquid, and g, which is gravitational field strength. Now, if you were to get rid of half of the liquid, অর্ধেক liquid তুমি যদি সরাই দিতা, তাহলে কি হইতো? It would become half h. So what would happen to the pressure? Pressure অর্ধেক হয়ে যেত. Does this make sense? All right. Now here's something you need to pay attention to. Say we do this experiment again with a tube which is the same height as the previous one, but it's larger. Cross-sectional area is greater. Do you get it? So এটার area ধরো A2 আর এটার area A1. So A2 is greater than A1. তাহলে কি হবে? If you fill this up again with water, we fill it up with water, and your hand is here again, and you experience a pressure here. So a pressure ta, how would it be different from this pressure? It would have to be the same pressure, because pressure is basically H rho G, out of which none of these have changed. So কোনোটা যদি চেঞ্জ না হয়, তাহলে তোমার কি H rho G same থাকবে? What's going to be different between the two is the force exerted on the hand. Force is equal to what? Pressure into area. Do you get this? So the pressure exerted here and here are the same, but the force here is going to be less, and the force here is going to be more. এখন imagine if you এখানে যে প্রেসারটা, এখানে কিন্তু we're ignoring atmospheric pressure. এখানে the pressure acting on top. If you wanted to find the total pressure, তাহলে তোমার atmospheric pressure এখানে act করতেছে, right? You would add this to H rho G. এখানেও same, you would have to add up atmospheric pressure to H rho G. Then you would find out the total pressure acting on the hand, right? On your hand. ওই জিনিসটা তুমি calculate করতে পারতা. All right. So if you go higher up the tube, এখানে যে pressure হবে, if you move up, say the whole tube is full of liquid, এখানে সে pressure কি হবে? What's going to happen to the amount of pressure? Less. It would be less. কেন? Because the height of liquid above you is decreasing. Okay, what about you go to this height in this tube, and a tubeর মধ্যে you go to the same height. তাহলে কি হইতো? The pressure would remain the same, right? At all depths, because rho GH. It doesn't matter the cross section area কতটুকু বা কেমনে কি কোন ভ্যালু কিসে কি, doesn't really matter. That 2% clear? All right. Now we can go into the concept of barometers. So what exactly is a barometer? It's a device used to measure atmospheric pressure. And atmospheric pressure, and basically first we have to figure out how do we make it, or how does it start off. Oops. So barometer basically je jinishta kora hoy, how do we get barometers to work, is one typical example would be, say you take a big bucket, a really big bucket, and you fill it up with any sort of liquid, any fluid would do, and then what you do is you submerge a really long tube under the bucket's water হইতে পারে, mercury হইতে পারে, any fluid, এরকম submerge করলাম. Submerge করার পরে কি করবা is you raise the closed end of the tube. এটা কিন্তু you have to ensure that the whole thing is full of the fluid. There's no air stuck inside. Right? তারপর আস্তে আস্তে এটা তুমি raise করা শুরু করলা. So এটা raise করলে কি হবে? আস্তে আস্তে say you start taking this out of the liquid and একটা certain height পর্যন্ত উঠাইলা. What you're going to see is after you cross a certain height above the surface of the liquid, এখানে there won't be any liquid. ঠিক আছে, এই জায়গাটা empty আসবে. Alright, does this make sense? So এটা কেন empty আসতেছে? এখানে basically what's happening is you're getting a vacuum. Alright? So why do we get a vacuum here? It's because, first of all, when we put the tube into the liquid, it was completely full of the liquid. As you raised the end of the tube from the liquid, why was it that there was liquid here? এখানে কেন liquid ছিল? It's because the atmosphere was pressing down on the surface of the liquid here, and এটার কারণে it was pushing the liquid up the tube, তাই না? Now the atmosphere can press down and it's going to move up because it's a vacuum here. So it's going to move up as long as the column of liquid, যতটুকু হচ্ছে, say this length of liquid, this height is equal to how much pressure the atmosphere can exert, or how much force it can use to push this liquid up the pipe. So basically, if this was a liquid of low density, it would push it very high up, right? If it's a liquid of high density, it would not be able to push it up that much. Alright. So you can use this actually to find out the pressure difference between 2 points. Kun point? You can find the pressure here, and you can find the pressure here, and the difference between the two will tell you how much atmospheric pressure is. Can? Because we know the pressure here is, if it's a vacuum, what's the pressure here? 0 Pascal. Taina? And we know here the pressure acting is atmospheric pressure. So the pressure here, a depth there, is equal to the pressure here. Taina? So if we take this height h, and if we do rho g h, so P is equal to h rho g. Oh my god. H rho g. তাহলে কি হবে? You would find the pressure exerted by the liquid at this level, and this is equal to atmospheric pressure. যেহেতু difference by করতেছ আর এই value এখানে the pressure is 0, so it would be h rho g minus 0, but যেহেতু it's 0, you don't even have to write it, so that would be equal to atmospheric pressure. Is this clear to everyone? Alright, common questions that they ask. What would you see if the tube was wider? তখন গিয়ে কি দেখতা? If you use a wider tube? Same, it would go up to the same height, right? Again, because cross-sectional area has no function in this equation.
Sure. You measure the height from the top of the liquid or below?
You measure it from the meniscus here to the surface here. If this was water, তাহলে এখানে তুমি এরকম lower meniscus পাইতা, এখানেও lower meniscus পাবা, এই bottom meniscus থেকে bottom meniscus. এটার বদলে if it was mercury, তাহলে mercury it would be এরকম upper meniscus. Then you would measure it from the top of this meniscus to the top of this meniscus. Is this clear to everyone? Alright. So, another question that they ask is, say this experiment is done with water. এখন ধরো একদিন atmospheric pressure is 101 kilopascal. That's close to the average pressure. ঠিক আছে? Daily pressure কিন্তু vary করে. Atmospheric pressure changes. So, ধরলাম 101 kilopascal. So, if we did this with water, তাহলে what would be the height in the tube? কত পাইতা? Atmospheric pressure is equal to h rho g. Atmospheric pressure কত? 101,000 is equal to height ধরো x times density of water. এটা যদি আমরা মিটারসে height যদি আমরা মিটারসে হয় তাহলে density must be in kg per meter cube. So we say 1000 times g is meters per second, right? So এটা হবে 10. It's important that you do meters per second এখানে, কারণ এটা তুমি যদি সেন্টিমিটার করতা তাহলে এখানে গিয়ে আবার সমস্যা, because this is in meters per second. So all of them have to be in the same value. So what do you get? X would be 10 meters. 10 meters is pretty high kintu, right? It's approximately the height of 3 stories. Ekta building er 3 tala porjonto 10 meters. So that's why we don't make barometers using water. Instead, we use what? Mercury. Mercury is something which is 13.6 times denser than water. So its density is 13600 kg per meter cube. So that means the height of the liquid would also be less. So this is usually around, it varies depending on the pressure, it would be something around 0.76 meters, okay, so, or 76 centimeters. This is approximate. This varies. Usually weather forecasting, they talk about pressure in millimeters of mercury. So 760 millimeters of mercury would represent a certain amount of pressure. Is this clear to everyone? So this is how we use barometers. So barometers usually are designed with mercury because mercury density is more, so you don't have to make a barometer which is 3 stories high. Is this clear to everyone? Guys, over? Alright. Achha, tabure this are manometers. What's a manometer? What does it do? Achha. Manometers are also called U-tube. Okay, sir? And it's used to measure pressure differences. You can't directly use it to measure atmospheric pressure. You have to know atmospheric pressure beforehand if you want to find out what the absolute pressure of something is. By that, what I mean is, first of all, let's understand what a U-tube is made of. So it's basically really simple. You have a tube of, say, glass or something transparent, and erokom kore ekta U-tube banano hoy, and we pour some liquid into it. So whatever liquid, doesn't really matter. Dhoro a height porjonto amra liquid pour korlam. Now, if the tube is held perpendicular, straight up, তাহলে দুই পাশেই the level of the liquid would be the same. কেন? Because both sides are open to the atmosphere. Atmospheric pressure acting here and atmospheric pressure acting here would be the same. So we could say the pressure here is A naught. The pressure here is also A naught. যেটার কারণে কি হইতেছে? There's no difference in pressure. Now, ধরো you connect an air pump to one of these sides. ঠিক আছে? এরকম করে তুমি একটা air pump connect করলা. What would you see happen to the levels of the liquid? What would you see happen to the levels of the liquid? It would push, the pressure here would increase, right? Air pump dicho. So it would push the level of this liquid down. And eta joto nambe, it's very important you understand this. If this moves down by a distance x, this will move up by a distance x. Clear? So this moves down by a certain distance x, dhoro ekhane chole ashlo. And this moves up to here, so ekhane chole ashlo. So now we have a height difference between the two sides of the tubes, right? A level and A. ঠিক আছে? So এই দুই ইয়ার মধ্যে, this is the height, right? Is this making sense to everyone? Now, the pressure here, because আমরা কি জানি, there's this rule, pressure is equal at the same depth, right? How do we know this? Pressure is equal to H rho G again. So if height doesn't change, by height here, say we take a dip into the ocean and you dive to a certain depth in the ocean, say this is H, alright? So you're swimming here and there's fish and stuff. You're there to see the fish and everything, I don't know. That's okay, fine. Happy fish. So now, say this person, he swims around this depth. Take us 8 depth there. He's going to swim around. The pressure acting on him will remain unchanged. How much is the pressure? Is the pressure of the atmosphere plus the pressure due to this depth of liquid. Does this make sense? Now, if he starts to rise, when erom kore jodi uthe ekhane ashe, তাহলে the pressure acting on him will be less because এটা কমে গেল, and if he goes deeper তাহলে the pressure would be more. So basically, if you're at the same depth, the pressure remains unchanged. So এখানে the pressure is the same as here, তাই না? Do you get it? So let's say we call this pressure P1, and এটা হইতেছে the pressure open to the atmosphere. Say we call this PA, right? So we're trying to find out the pressure exerted by the gas, which is basically P1. So the pressure here is also what? P1. Does this make sense? Acha. So eta gelo separately. Now if you look at this point here, what's the pressure here due to the stuff above it? It's going to be rho GH or H rho G due to this plus atmospheric pressure. So you could say the pressure here is, the pressure P1 is going to be what? Atmospheric pressure PA plus H rho G, right? This is equal to P1. So the pressure here is also PA plus H rho G. So you find the pressure here. এখন যেহেতু বলছিলাম it measures pressure difference, that is basically the H rho G. If you want to know the pressure difference between atmospheric and P1, it's just simply H rho G. And if you want to know the pressure here, you need to know atmospheric pressure. This device by itself cannot measure atmospheric pressure. It can only measure differences. Alright, এখন আমরা slightly different একটা setup একটু দেখি. Say we have another U-tube, and this time we connect this to a partial vacuum. ঠিক আছে? So what's going to happen? It's going to pull the liquid up. উঠাইতে ধরো, it's going to stop at one point. Initially it was at the same level. ধরো তারপরে এরকম হয়ে গেল. Alright, now this should be easier. The pressure acting here is what? Pressure acting here is atmospheric pressure, so PA. Right? তারপরে কি হইতেছে? So the pressure here is PA, so that would mean the pressure here is also what? PA, atmospheric pressure. So if you move up above PA, pressure বাড়বে না কমবে? Kombe. Obviously the pressure is going to decrease. So it's going to be less here. Less by how much? Less by the height. So basically the pressure here, let's call this what is the P1, let's call this P2. So the P2 is going to be what? It's going to be H rho G less than PA. So you just write PA minus H rho G. What you have to remember is this is the total pressure acting at P2. If you want to know how much it's less than PA, it's just H rho G. If they don't give you the value of PA, তাহলে তোমার just H rho G দিয়েই কাজ করতে হবে. If they give you atmospheric pressure, that usually means you have to use it in some sort of calculation, obviously, right? So এটা করলাম. Similar questions that they ask here. Number 1, tube যদি wider use করো তাহলে কি হতো? What would you say? It would be the same thing, right? কারণ the width of the tube has no effect. Again, H rho G. Acha, what change would you see if you change the liquid with something which is less dense? The change in height would be more. Why would we want this?
Easier to handle, more and bigger.
It's actually sometimes easier, right? The same pressure will cause a bigger height difference. It's easier to measure a bigger height difference. Small, যদি ওইখানে heavy liquid দেওয়া হতো তাহলে height difference would become too small to measure. Does this make sense? And যদি তোমার করা হইতো কি জানি বলে if you use a more dense liquid, what's the advantage?
Large pressure difference.
Yes, যেহেতু তোমার ওইটা একদম এই মাথা পর্যন্ত উঠাইতে you would need a huge amount of pressure. You would actually be using something which has high pressure, right? So you can actually measure very high pressures. Do you get it? So extremely high pressures পর্যন্ত মাপা যায়, and that's what you could do to use this. So is this clear how you use manometers, guys? So we're done with manometers and barometers. Again, if we go through the points of the syllabus, again basically simple mercury barometer measuring atmospheric pressure. Use and describe the use of a manometer. And in all cases, we use the formula pressure is equal to H rho G. Clear? All right then. Done.